nothing but against the party. Ain't nothing but against the party. Ain't nothing but against the
Alright, so I'm going to give you the lowdown on forces, okay? A force is a push or pull upon an object resulting from the other object's interaction with another object. For example, if I push this game of tabletop bowling zombies across the table, I am exerting a force on it because it's moving. So, forces are measured in newtons. By that I mean that's the unit, like if you were finding force. 1 newton is the amount of force required to give a 1 kilogram mass an acceleration of 1 meter second squared. So if I were pushing this along with, if this was 1 kilogram and it was moving at 1 meter per second squared that was accelerating at, that would be 1 newton. However, I can't really calculate that right now. But there are all different kinds of forces. There's an applied force, like if I was pushing on this. There is the force of gravity, which is, you can't see it, but obviously it's there because this happens. There's the normal force, which is this table pushing back up on this. Tension force, which will explain, basically, I just wanted to explain what force is, in case you didn't know, so you didn't get confused. So basically, I'm going to say it one more time. A force is a push or pull upon an object resulting from the object's interaction with another object. So, yeah, it's pretty much forces. Alright, so I'm going to explain to you what Newton's third law is. Newton's third law says that for every action, there's an equal and opposite reaction. For example, if I throw this ball at the wall like that, the action is the ball hitting the wall, but whenever the ball hits the wall is also pushing back on the ball, and it's equal in magnitude, but opposite in direction. For example, if there's a bird flying and it's flapping its wings, like up and down, the bird's wing pushes down, but the air pushes up in the opposite direction, but equal magnitude. Like Newton balls, things go click, click, click. Whenever it goes that, it hits, the magnitude is the same, but the direction is opposite. And as you can see in the video of the scooter, when I am riding and I do my jump, my brother tries to do his jump but does really bad, I kick on the ground, but the ground pushes back onto me because that's just a law of physics that Isaac Newton discovered, and it's underappreciated. Like, if you didn't have it, you'd try to do that and nothing would happen, or you'd fall through and be really sad. You wouldn't be able to scoot anymore. So basically, yeah, the third law is for every action there's an equal and opposite reaction, and it is an opposite in direction but equal in magnitude.
So for our next concept, distance versus displacement, let's say we decide to take my dog for a walk, but since she's lazy, we only go 1 house down. Every step we take away from the original starting point, our distance and displacement increases. But as soon as we decide to turn around, our distance continues to increase, but our displacement starts going back towards 0. Our distance is the total amount of units that we've traveled, while our displacement is the amount of units we are from our original starting point. So no matter how far we travel, or how many steps we take, as long as we end back up at the house, our displacement remains 0 while our distance varies.
Okay, so now we're talking about speed versus velocity. Okay, so in the previous video we saw my dog who started off at a point, traveled all the way up here, and then came back down and finished straight here. He's traveling north that time, and he traveled a total distance of 11 meters. However, his total displacement, which is from the initial point to the final point, was 5 meters. Okay, now we're going to solve the velocity. Now velocity is equal to the total displacement over total time. So velocity is going to be equal to the total displacement, which was 5, over the total time, which was 7 seconds. And that's going to equal 0.71 meters per second. Now with velocity, you have to include the direction of travel. So my dog was traveling northeast from here to here. Now speed. Speed is equal to the total distance over the total time. So speed's going to equal the total distance of 11 meters over the total time, which is 7 seconds. That's going to equal 1.6 meters per second. And that was the speed. Okay, so this shows us that there's a big difference between speed and velocity. Speed is a scalar quantity, and it is not direction aware. However, velocity is a vector quantity and is direction aware. So anytime you write velocity, you have to include a direction. This shows that although the dog started and finished at the same point, the velocity and the speed are not the same because the velocity depends on the direction and the speed does not.
Alright, so I'm going to explain to you what acceleration is. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it changes velocity. So basically, acceleration can either be an increase in speed, a decrease in speed, or a constant speed that is changing directions. So you could have a car that's at a stop and it gives it some gas and it starts going forward and increasing speed. That could be acceleration. And a lot of people only think of that as acceleration, they think of it speeding up, but it doesn't necessarily mean speeding up. It could also be a car that's driving and it taps the brakes and it starts to slow down. That's also acceleration because it's a change in velocity. Even a car that's going at a constant speed, not a constant velocity, if a car is going into a corner with a constant speed, it is technically accelerating because it is keeping the same speed, but it is changing velocity, so therefore it falls under acceleration. Okay, so to find acceleration mathematically, there's a formula you need to use. Assuming that you're given these variables, you can find acceleration by dividing the change in velocity by the change in time. Most of the time you won't see it written like this. You'll see it like this, where a equals velocity. This means delta. Delta v is change in velocity, and delta t is change in time, which is the same thing right here. So right here I'm accelerating. You can't hear the engine because I had to cut the sound because Morgan said some words she's not supposed to say. Alright, so I'm going to show you how to find acceleration, and for this I'm going to use the numbers we found from when we drove the Subaru through the parking lot. So the car speedometer measures in miles per hour, but I went ahead and converted it to meters a second just so it'll be easier and easier for you to understand. So you define your change in velocity, you do your final velocity minus your initial. So your initial is 11.176 meters a second minus your initial, which is 0, and that obviously is just 11.176, no change. And you take your change in velocity and you divide it by your time. So your time is 4.25 seconds. Now if you take it on your calculator right here and you type it in, you get an answer kind of like this. See how I typed in? I just did 11.176 divided by 4.25. It's pretty simple. And we're just going to go ahead and round it to the hundredths place just because of sig figs. So the answer is 2.63. And you're going to want to put a unit on this, obviously. If you've ever been in any math class or science class ever, you know you obviously need a unit, or else the number is pointless. And acceleration is generally measured in meters a second squared, which is what it is here because it's in meters. But be careful when you get a problem. It might be kilometers a second or kilometers an hour. You might have to convert it, but generally leave it in meters a second squared. And that's pretty much acceleration.
Free fall is when an object is falling, and the only force acting upon it is gravity. On Earth, the acceleration due to gravity is about negative 9.8 meters per second.
Squared.
So let's say Jacob, instead of running, decides to fall off the ledge. The ledge is about 3 meters tall, and his initial velocity is 0 meters per second. We're looking for the time it will take Jacob to reach the ground. The equation we're going to use is distance equals initial velocity times time plus half of acceleration times time squared. Once we plug in the numbers, we get 3 equals 0 times time plus half of negative 9.8 meters per second squared times time squared. 3 equals negative 4.9 meters per second squared times time squared. Once we divide 3 by negative 4.9, we get 0.6122 equals time squared. Once we get the square root of that, we can determine that it will take Jacob about 0.78 seconds to reach the ground.
Alright, so I have here an extremely rare 8-pound weight. Okay, so I'm going to explain to you the difference between